Hello. If you're watching this video, you've been tasked with an important mission. It's called learning. This video will self-destruct, as will YouTube, in 5. No, I feel like I'm zoomed out really far. My camera's crooked. Oh well. I'll have to put up with that for one short video. I'm trying out different lighting configurations too. So who knows if this is any good. Okay. A few weeks ago previously on EGR 3, 2, 10. I forgot what class I'm in. Dun dun dun. You found out the maid was the killer. You discovered that the butler is secretly a federal agent. And you found out that the master of the house was actually a robot. Now tune in to this exciting episode where we will reveal who the robot's maker is. So previously on EGR 210, what we talked about was Gantt charts. Gantt charts are a way of organizing your time into a visual progression such that you understand the tasks that are being done and the time frame that they're being done in. We give a very brief overview of Gantt charts. I didn't expect you to do that in class. I will be expecting you to do that in Project 2, so you'll have to go back and watch some of those lectures. But ultimately, what the Gantt chart does very well is the Gantt chart takes tasks and gives a timeline. It's basically just a visual form of a timeline. I like Gantt charts because they're a little bit more aesthetic than just saying, here is time. And it allows for multiple things to be done at the same time, which is necessary for any group because if you remember back when we talked about teamwork, a properly organized team will operate such that every person is able to do something simultaneously. Everyone will stay busy all the time. The moment you have group members that are waiting on somebody else to finish their part of the project, things start falling apart very quickly. And then you have group members that are just sitting there like, I don't know what I'm doing. Which I know some of you are doing for Project 1. So, yes, I know. We could have talked about this and we could have organized this before Project 1, but it's a learning process. So, what we're going to be... Oh, another thing that we talked about previously, specifically last week, was we talked about project selection. This is the idea that how do we know what projects to undertake? How do we know what decisions to make about those projects? In the project selection, we talked about pro-con analysis. That stands for professional convict. Just so that you know. No, I'm kidding. And then SWOT analyses. We just briefly mentioned those. Again, I didn't expect you to do an example of them. You will need to do those for Project 2. So, all right. So what we're going to be discussing today is kind of a culmination of these principles here, and it goes into what is commonly known as the proposal. But this is a little bit more than just a proposal, because if I remember back to the syllabus for this class, proposals are actually next week. So what we're going to be discussing today is kind of the preliminary language that's needed for understanding proposals. Okay? Yeah, so we talked a little bit about project management before. Project management does involve project planning. Okay, project planning is actually a critical role in project management. And what is project planning? Well, it's sitting down and actually creating estimates for resources. So one of the things that's required in project management is they have to allocate the resources, you have to find the people who are going to fill the roles, you have to find the money that's going to work for this project, etc. All of those things. Well, project planning, it's determining the values that you need to know in order to do proper project management. Like, how do you know how much money to go raise? Well, if you do good project planning, you will know. Okay? This is also called, in a loose sense, estimation. Project estimation, component estimation, that kind of thing. A lot of what you do for project planning, I think David Ullman, he is one of the great minds in this area. He's put together a form that's present in your book. Who knows if you can see it because I shifted all the lighting. This is on page 129. You can feel free to screen capture that if you really want a good picture of it. It's the nice thing about posting these to YouTubes. But this gives one example of one component of a project plan. Okay? And ultimately what's shown in here is you have a task, you have the name of the task, the objectives, deliverables, decisions, personnel, time, and the order in which this task will be accomplished, expected start date, expected finish date, how much it's going to cost, what kinds of costs are going to be associated with it, etc. And he does have some control documentation at the bottom which states, here are the personnel who's looked over this project plan, here are the people responsible for it, here are the person who signed off on it, here's the date when it was written up. All that just makes it more official documentation. And yeah, we will be dealing with official documentation in this class, so it's important to be familiar with why some of those things are present. So when we go through project planning, it's pretty straightforward. Okay, first thing you got to do is you got to identify the tasks associated. Okay. And here, I'm not going to call it a task, I'm going to call it goal. For risk of redundancy there. And what I'm going to do then is I'm going to take this and I'm going to say, okay, so let's say your design goal is you want to create design goal or project goal or whatever it may be. Let's say your design goal is that you're trying to create a GPS sensor or a proximity sensor for like your cell phone or your car keys. Then you could provide a description. And here the description of this would be a device that allows you to determine how close you are to the other receiver. And there are like tags, and there are square devices that have been put out that will actually beep based on how far away you are from them and stuff like that. That's very much the same principle. We're designing something like that, okay? And our whole goal is, let's just create something that lets us find stuff like your keys. Maybe you could put a small strip on your glasses if you constantly lose your glasses. If you're like me, you could put it on absolutely everything you own, because I'm lucky to be wearing pants today. So it's just that's the description of what we're trying to do, okay? So this is the overall design goal of what this is. So we have proximity sensor. Now, some of this takes a little bit of engineering experience to understand how to break down this task, but you got to break this down now into multiple subtasks. Okay, and breaking this down into multiple subtasks is no small feat. It actually takes a lot of vision, and it does take some experience, as I said. So the pieces that would be involved in this are, first of all, you have to develop a communication device. In order for it to understand proximity, there has to be some form of communication. A beep, maybe it is a display that shows on your phone. Who knows, maybe you could integrate it with your camera sensor, where scanning it around the room would allow you to show a location or something. It's an interesting concept, but you have to figure out some form of communication. How are you going to locate it? Then you have to figure out the battery, okay? There's going to be some power consumption to a proximity sensor. It's impossible to have a sensor that just simply doesn't consume power. It would have to absorb power from the atmosphere in order to send any information, because it does require power to send information. Information is inherently power, believe it or not. So it's going to require some kind of power source. And you're going to have to figure out what that is. What does the power source look like? How's it going to find that? And then lastly, how do you, quote unquote, ping it? How do you activate it? So that it's not just constantly beeping like, oh, my keys are in my pocket. Yeah, I knew that the last time you beeped, 5 seconds ago. There has to be a way of sending an information signal to the device to say, hey, provide me with your location. If you do it this way, so that there is a route for communication and control over when it communicates, then you're going to limit the amount of power that's consumed by that device. Okay? If you have to plug in a desktop computer under your glasses just so that you can, you have to walk around plugged into the wall. Or you have to charge your glasses every night, which would be ironic, because if it runs out of battery, you can't find it. Although if it's connected to a laptop, you probably wouldn't have struggles finding it. You'd be walking around like this a lot, but so be it. So I'm gonna say these are the three main tasks involved in designing a prototype of a proximity sensor. Now, I'm going to take a step back there, okay? If my goal is to manufacture a proximity sensor, this is only one small step of that design process. And in fact, developing a prototype, if you go back and look at the engineering design process, that's step 3. Okay? Which means in order to put this together, you'd have to talk about steps 1 and steps 2. How are you going to do the background research? How are you going to step back and create ideas? How are you going to come up with these ideas? Which this pops up, a lot of this pops up as tasks that are required based on functional requirements. Okay, your communication, this has to be something That would be a functional requirement that is sends a signal, sends a location. Okay, is powered. And lastly, is controllable. Okay, it's based on the functional requirements which are developed in step 1 of the process. So if we go through step 1, assuming we've done the background research, we already know what kind of devices are available, and we decide, hey, we're going to build one of these anyways. Then we move into step 2, where we take all these ideas and we say, okay, how do we ideate? And that's part of what this process is it's kind of jumping into the step 2. Step 3 is plugging them all in together, which that would be another piece of this, which another task to do would be a full construction, which would be the development of the prototype, and then testing and analysis. Okay, so here you have your ideation phase, which should involve some scientific research, some putting things together, finding out if they're feasible, finding out measures of quality about those different ideas so that you can find a best solution for how to communicate, what battery to use, and how to ping it. You put that into a full construction. So these 3 have to be constructed first, and then you move into this, and then once it's been constructed, then you move into this. And so there's kind of phases to this project, okay? A total of 5 tasks, but 3 phases. Okay, and full construction may involve multiple tasks as well. So, as you can see, I mean, we're breaking down into multiple tasks very quickly just based on our design process. Ideation, we're assuming that step 1 is completed with design, the problem definition. This is step 3, this is step 4. Each one of these are going to have associated, okay, I'm going to build the full construction, I'm going to have to design a control board that everything is going to be mounted to. Okay, that'll be one of the tasks associated with this, and they can be done independently. Solder components to the control board, that's another task that has to be done. Connect battery. That's another task that's going to have to be done. And all of these are individual tasks that are associated with this. And when we go down and we break it down into the types of tasks that have to be done, I mean, you come up with a lot of tasks. And this can be built out even further. Maybe as a study of communication, you're going to be doing research on communication devices. Maybe you're going to be purchasing communication devices. Maybe you're going to be developing the code for communication devices. It's going to involve some coding. Maybe it involves finding different GPS signals. Maybe it involves finding Wi-Fi communication. What is the ability for it to send a location, and what kind of sensors are associated with that, and how do you go about designing that? Well, I mean, all of those are just trial and error processes where now you have a mini design problem. Step 1, do background research on communication. Step 2, find what kind of devices already communicate. It's just a problem within a problem within a problem. And that's really what a lot of engineering is. It's tiny problems that all sum together to form a giant problem. Okay? So this is kind of an example of what I mean by break it down into multiple tasks. Now, I know a lot of what those tasks would have to be because I've gone through the design process, but for a lot of novice engineers, it's identifying those tasks can be a big challenge. And that's going to be a hard piece of what is Project 2 for you. We'll step you through how to do that when you do it. But once you've broken this down into now multiple tasks, the second step is to look at each individual task. Individual. And determine its resources. Okay, how much money is going to be required? What all steps are going to be involved in that task? Okay, because even though you may be working on a sub task, there's going to be sub tasks. And that's really what every problem is. It's you accomplish the sub tasks so that you can finish the sub task. And then once you've finished that subtask, you can move on to the sub task, and then you build out the little individual pieces to eventually build a bigger piece, and then you work on the little pieces, the next one to eventually create the bigger piece, and then you work on the little pieces, the next one eventually create the bigger piece. You take these bigger pieces, you put them together, and you create a bigger piece even still, and then you work on that, and then you go back and you work on the smaller piece of the next one. And it's just a very iterative process of solving the most base level problems, putting them all together, coming up with a bigger solution, taking all these bigger solutions, putting them together, getting an even bigger solution, taking all these bigger solutions, putting them together, and eventually you get the full solution. And that's really all that engineering is just putting problems together and doing a lot of problem solving. Okay, so here looking at each individual task, identifying subtasks, and then allocating resources to those subtasks, which eventually comes up with that. Okay, although before resources, I should say that this is probably 3. This is definitely 2. What do you need to be the final step? How do you know you completed a step? Well, the way that you know is by identifying deliverables. Okay, if I go back to my example that I drew on the board, for communication, the deliverable is have a communication device that tells proximity. Once I have that device, once I have it selected, once I have the device configuration, that is my deliverable for that step. I'm done. I do not need to focus on communication anymore because that task is completed. Okay? So when you're looking at deliverables, it's how do you know your steps are completed? What did you actually physically create that finishes that step? Because it's important to identify what is the end goal. What is this intermediate goal that you're going for in order to get the end goal? If you understand deliverables that are needed at the end of each task, then you'll have a really good outlook for how you can progress because you're working towards those deliverables. And then when those deliverables are done, you're working on the next task, you're working towards those deliverables. And you know that at some point, all those deliverables are going to come together because you've done proper project planning to produce a final product. Okay, so second step is deliverables, not quite allocation of resources yet. Third step, according to David Ullman, is decisions. Okay, which are we going to use? How are we going to use? How are we going to do this? What are we going to do? These are the kinds of decisions that are needed. And this kind of goes along with the deliverables of identifying how are you going to know when the task is done? Well, one of the things is that you have correctly made these decisions, or at least that you have confidence in these decisions. And these decisions are oftentimes going to influence what the deliverables are. So here, what is the best communication way? That would be a decision that has to be made in our communication. Second, what is the best power source? That's a decision that's going to have to be made based on this. And this, I mean, you may get it wrong, but you can always come back and fix it later. If you have your project planning done correctly, you have so isolated each of the individual problems that you can go back and fix them very simply. So after you've made what decisions you're going to make as a part of that task, then what you do is you allocate the resources. Okay, and this is people, hours, money, space, technology. It's any kind of resource that can be used for this task. When you've done this, you will have basically said, okay, I need all of this for this task to be completed, to make this decision so that I can produce these deliverables. It's kind of working back up the scale here. And once these deliverables are done, that's how I satisfy the tasks. And this is the steps. And then you would repeat steps 2 through 4 for the next task. and the next task, and the next task, and the next task. And you may have inside of here, you may have to, one thing that David Ullman says is he actually talks about in here the progression of the sequence of design, how this is going to work. That would probably go in right here if you want to put in a design sequence of what it's going to be, the actual flow of topics. And that usually is nice for planning, although that type of information doesn't usually show up in a proposal. But then it's just doing this, all of these over and over again until you have all of the tasks completed. And that is what project planning is. It's a very iterative process. And don't get me wrong, it's a very time-consuming process. Figuring out how many people hours, how much money, how much space, how much technology. Sometimes you have no idea. And sometimes you're just throwing out numbers. Sometimes you have to go look at past projects, similar projects, see how the money was spent. Sometimes you have to go and you have to contact administration about whether or not certain technology or space is going to be available. Sometimes you have to find people or find people who can do this so that you can allocate the people hours correctly and say, okay, we're probably going to use an engineer for this one, which we're going to need that, but we could probably fill in the rest of the people technicians. We're just going to do what the engineer tells them to do. Well, that'll save some time, but it takes time for you to go back and pick through how many people hours are going to be needed and what type of positions are going to fill those people hours. So project planning is not altogether easy. I am going to make you do proper project planning for project 2. We'll talk through it when we get there. It's a lot of just busy work, but you will need to do that. And you'll have to have that done before we even jump into SolidWorks. So we're going to be talking about project planning. My goal was that when I introduced proposals that we were going to start working on the project planning to create a proposal, but it looks like the way that this class is set up now, we're going to be talking about proposals about a week before you get started on it. So it happens. We have to be flexible. But that is project planning, okay? So there we go. I'm not going to jump into an AutoCAD lecture. I might post a bunch of AutoCAD lectures this week just to try to knock out all of them. I know I was going to try to post more than I did last week. I didn't end up doing that, obviously. But I'm thinking this week, if I can just knock out all the AutoCAD lectures. For those of you who are in the Thursday section, next Thursday is your presentation. So if I can get you all the AutoCAD lectures this week, then you can work on it all the way up until Thursday if you really want. But I would prefer to give you those lectures this week rather than wait till next week and then, oh, by the way, you have 3 days now to do this. So that's why I'm putting a little bit of a rush on that. But I'll work on that. I'll probably be able to get one out today. Tomorrow we have off. I was planning on taking and creating a few of those lectures tomorrow. So that's my plans. Okay, feel free to email me with questions. Keep working with your group because deadlines are coming. And these deadlines are not something that I can extend. I gave you enough advance notice that I feel like you should be able to put together something in a month and a half. All right, I'm going to switch